Hi everyone. Today I'm going to help you prepare for the next phase of what you're going to be doing. We are now prepared to really project out quite a long ways into the future, way beyond the data we have currently collected, because now we have figured out how to make a prediction that accounts for weather, that includes weather, and now I think we can actually make some pretty good predictions, which is exactly what we're going to try to accomplish here today. What we're going to need to do is for each month that we don't have data for, we got to make a prediction for that month. For a whole month, we got to predict what the total electricity is going to be for each of our upcoming months so that we can expand this out to like the whole rest of the year. How are we going to do that? So far, all we've done is predict the total electricity produced for a specific day. We know how to do that. We've seen this. You just finished doing this in the previous task. If I give you a day, what you need is you need the day of the year. That, of course, comes from this sheet here if you need to figure out what day of the year is what. So November 1st would be, 5 days before November 6th. Day of year is 305. You can find the solar intensity. What do you have to do to find that? You have to go to this little handy calculator business. You've got to type in 305. You've got to get the sum of all of the solar intensities for that day, and you got to write it down, which is what I've done here. And then we've got to correct it. We got to correct it because we know this total solar intensity, that is only true if it's totally sunny. It's not totally sunny. In future months, obviously, we don't know how many clouds are going to be in the sky. I mean, that's impossible to predict. But what I do have for, and you have access to this handy little bit of information, we've got, on average, how much sunlight we can expect for any given month. And for the month of November, it has 50. That means 50% of the total amount of sunlight you could get. If it was totally sunny every single day, well, it's not sunny every single day in November. And on average, you only get half of what we'd normally get. So that's what I've done here. I've taken my total solar intensity, I've corrected it by dividing it in half. And then how do you predict how much electricity is going to get produced? You use your prediction equation. We've done that. Now the question then is, how do I get the total electricity for the month? Now, the first obvious thing is, just go ahead and calculate it for every single day of the month. Does that sound fun? Does that sound like something you want to do? It's actually not the worst thing in the world. It's not the most tedious, but it's pretty tedious. And if I were trying to work through this problem, I'd be thinking, nah, I don't want to do that. That sounds terrible. There must be an easier way. Well, there's several different options, turns out. Are they perfect options? Maybe yes, maybe no, but they might prove to be pretty good. Because here's what I'd be thinking about. I could look at, and I've calculated a few random days for you here just to give you a feel for what these numbers are going to look like. We know that over the course of the month, the total solar intensity is going to go down from this, 19,000 at the beginning to 14,000 near the end. And one thing you could actually kind of take a look at here is is the decrease pretty steady? We actually could find that out by making a graph of this. If it declines pretty steadily over the course of the year, of a month, that might be kind of handy. Now we know it's not a linear relationship. It's not gonna be. But it might be close enough. And as I look here, that to me looks pretty steady. Over the long term, over the course of a whole year, this would not be a straight line. It's going to be curved. But for the time period we're looking at here, that's not so bad. So what that indicates to me is that what I could try to do is, instead of calculating this out for every single day, I could simply observe that, wait, I've got 30 days in November. If I knew on average how much electricity I'd produce on any given day, well, then all I'd have to do is use that average and know that I got 30 days in the month and I can get a total. Makes life much easier. How could I find an average? Well, I could think of several different ways. say average electricity produced for November. Here's one option. Maybe I just look at the day that's right at the middle of the month, the 15th of November. That's right in the middle. In the earlier days of the month, I'll make more. Later days of the month, I'll make less. And it goes down at a steady rate, so maybe I just pick the midpoint and say, you know what? Let's just call it 11,504. That's one option. Another way you could take an average is say, well, I start here and I end here. I just take the average of those two. 11,777. Those are pretty similar, right? Of course, if I really wanted to know the average electricity produced for the month of November, what would I have to do? I'd have to calculate every single day and take the average of those, and that is, oh, that's tedious. I'm trying to avoid that. Maybe I take it and go like every 5 days and average those. I don't know. My guess is no matter which way you do it, you're going to end up with something really similar here. Somewhere around 11,500 to 11,700 or something along those lines. And honestly, those numbers don't differ very much. That's a pretty seems like a pretty solid estimate to say that that's what our average is going to be. So what's the total electricity for the month? It's just whatever our average is. I'll use the 11,777 option times 30. 30 days. Boom. Well, that was easier. I like that. I'll leave it up to you how you want to estimate the average produced for a given month. Totally your choice to do. One thing to think about and be a little careful of, we had a month here where you had a steady decline in total solar intensity. If you pick a different month, it may not always be the same. It may not have that same sort of pattern. You gotta think about that a little bit and be a little bit careful. A month like December, for instance, that could be a weird month because December 21st is the shortest day of the year with smallest total solar intensity. So that means if we looked at the pattern of intensities, they're going to go down for a while and then they're going to start going back up. That could get a little weird. You have to think about how you might want to approach some of those weirder months. But at least for a month like November where you just have a steady decline, that's going to be most months of the year, either steadily going up or steadily going down. I think this is a pretty straightforward way to do it. And you can figure out the total electricity for any given month quite rapidly this way. So your next task is going to be to try to make an estimate, project out into the future, and come up with ultimately a number that will reflect the total amount of electricity we think we're going to get out of these solar panels for an entire year, which is pretty cool. So I'll leave you to it.